Last time we were taking a look at section 7.6, and we had gotten to the point where we had one final example of finding a centroid. And we talked about how a centroid is not that much different than the directions of the previous problems where we were finding center of gravity. It's simply that we know that the uniform constant density is actually equal to 1. Rho is equal to 1, which makes the calculations a little bit cleaner as we're working through them. So we were on this very interesting shape that we identified as an ellipse. And we talked about, while you may not have ever actually learned a formula for the area of an ellipse, it's very related to the area of a circle. And our area of this particular shape, that is the mass of this particular shape, is actually 1/2 pi and then a times b. Okay? So that's what we had done last time. So we're ready to actually take a look at finding capital M sub x. That's the moment. And the formula that we had for doing that was rho over 2, and our rho is 1, so here's the 1 over 2, times the integral from a to b. Well, the integral from a to b means the integral along the x-axis, and so our a and b, if you will, are actually negative a and b. And if you wanted to, you could actually go from 0 to a and then double it. That would be another way to do it. I'm going to show it to you from negative a to a because things are going to cancel out nicely either way we do it, but recognizing that as we're doing this, it is a symmetric graph.
I have a question.
Yes?
If you were to do it from 0 to 8, since you have to multiply by 2, wouldn't that just close out the half?
It would. Yeah. All right. We had a formula for finding this. What was our formula? What did it actually ask us to calculate? Do you guys remember from last time? It's been a little bit, I know. Let me find it over here. That's the one. All right, so we had f of x plus g of x times f of x minus g of x. Do you remember that? And it was over rho, which was, I'm sorry, over 2, which we moved to the front, so I don't need the over 2 part. But we have the addition of the two functions, and we have the subtraction of the two functions. And what do you notice about the two functions here? What are our two functions? Yeah, one of them is the y equals b over a square root of a squared minus x squared. What's the other one? Yeah, it's actually 0. So when I take this square root function and I subtract 0, and I take the square root function and I add 0, don't I just get the square root function either way? Times itself. So it'll be squared, exactly. So my function actually ends up being b over a times the square root of a squared minus x squared, and it's all squared. Yeah, it feels like that's not the same formula, but because we have it subtracting 0, the x-axis at y equals 0, it is. So I have negative 1/2, the integral from negative a to a of b squared over a squared. Those are just numbers, right? Okay, I'll take that as a yes. And then I have a squared minus x squared dx. So just because I can, I'm going to go ahead and pull the b squared over a squared out in front with the 1/2. So I have b squared over 2a squared. And then I have the integral from negative a to a of a squared minus x squared dx. All right, so what's the antiderivative of a squared? No, try again. Careful. A squared x. Okay, a squared is just a number, right? It's not a variable. We don't know what number it is, but it is just a constant number. So this is a squared x. If it were doing the derivative, it would be 0. And then what's the derivative, antiderivative of negative x squared? Yeah, 1/3 x cubed, or x cubed over 3. And we're evaluating from a down to negative a. Okay? So at this point, I actually in my notes, what I did is I went ahead and doubled the items that we had talked about before. So I'll do it here too, just in keeping with my notes. So I actually changed this at this point to recognize that this was symmetric. A squared minus 1/3 x cubed, going from a to 0. Yeah, we'll go to the next screen. I have plenty of space in here. All right, and we'll plug in a, and then of course plugging in 0 becomes 0, which is also very friendly. So I have b squared over a squared, and then I have a cubed minus 1/3 a cubed minus 0. Yes, was there a question? It canceled when I changed this from negative a to a. I doubled the area because I halved the area, the length of my x-axis, because it was symmetric. So the 2 went away when I changed my limits of integration, which I could have done at the very beginning. I don't know. I was just following what my notes did the last time I did it, so that's what I got. And then minus the 0. So what is a cubed minus 1/3 a cubed? Yeah, it's 2/3 a cubed. So what does this give me after I'm all said and done on this? 2 what? 2/3 what? AB squared. 2/3 AB squared, or 2AB squared over 3. Okay, so that's m sub x. Let's do m sub y next. All right, so what was the formula for m sub y? Do y'all remember? It's okay at this point, but you are going to memorize them, right? Yes, of course. All right, it was an integral from the negative a to a. And then what? Very close. It's minus, and this one it won't matter because I've got 0 as my g of x, right? Yeah, so it's x times f of x minus g of x, but our f of x is the b over a square root of a squared minus x squared, and our g of x is actually 0, so we just get this piece, dx. And we'll go ahead and do from the beginning what I didn't do last time and write this as 0 to a, 2 times 0 to a of the x over b. You know what, that's silly. Let me pull the BA out in front as well. 2b over a, and then I have x and square root of a squared minus x squared dx. Now, this one is not as nice as the last one because on the last one the square root canceled because we ended up multiplying it by itself. So what am I going to have to do on this one to solve for this, or to simplify? How am I going to have to simplify this in order to take the antiderivative? You really don't have a lot of tools yet to discuss. That's right. Say it louder for me, Abby. U substitution. Do you know what the U might be? Any guesses? Right. So we're going to do U substitution. Our U value will be what's underneath the radical, a squared minus x squared. What would du be then? Negative 2x dx. And I don't have the negative 2, so I'll of course move the negative 2 to the other side and pull that out in front, which is actually pretty nice because I already have a 2 out in front, correct? So this is actually just going to be negative b over a. And then I have the integral. I want to leave off the limits of integration because I'm changing them into u's. And this is the square root of u du. All right, square root of u, of course, is u to the 1/2. So what's the antiderivative of u to the 1/2? It's actually, okay, so it's 2/3, right? Okay, so we have a u to the 3/2. Some of you are saying that part of it. And then we should divide by 3/2, which is the same as multiplying by 2/3. Right? And then we're going to turn this back into the variable x. So this is, well, let's write it. This is negative 2b over 3a. And then it's the square root of a squared minus x squared cubed, evaluated at a and at 0. Now, this is the first example I think that we've done in class in quite a while that when we plug 0 in, we don't actually get 0. Most of the time we have, because most of the time we've been dealing with polynomials at this point in the problem. But this one we have to make sure. You don't always get 0 by plugging 0 in, and on this one you won't. So we're going to plug in a first. So what happens when I plug in a to this quantity? What happens? Yeah, you cancel, so what does it give me, Seth? 0. I'm actually going to get 0 on the first part of this one, right? Yeah, and then I'm going to plug in my 0, which is the square root of a squared minus 0 squared cubed. Okay, so the first piece, this all became 0. On the second piece, I have the square root of a squared, which is, no, the square root of a squared. I'm doing the second half over here. Yeah, this is just going to be a, and then I've got the cubed, right? So this piece is going to be a cubed. So everything that's being evaluated for is going to have the negative 2b over 3a, but then it's going to be a cubed. So I have negative.
Is that going to be negative a cubed?
Oh, and it's negative. Thank you. Negative a cubed. Yeah, because there's a negative there. Thank you. Yeah, so I'm going to get a positive, which is good. And so I have 2a squared b over 3. Or you could say 2/3 a squared b. Maybe I'll write it that way just because I did before. The other piece. Okay, so that's m sub y. We've already calculated the mass m. We've calculated the moments with for x and the moment for y. And so now we're actually ready to calculate x bar and y bar. So does anybody remember how do you calculate x bar? I know some of you have been working on your homework already, which is great. Good. M sub y over lowercase m, and then y bar is m sub x over our lowercase m. Fabulous. All right, so m sub y is the one we just found, and it was, what was it? 2 over 3 a squared b. And then divided by m. We did that last time. What would we find for m? 1/2 pi ab. Okay. And so my b's reduce. My a reduces with one of the a's in the numerator. I have 2/3 divided by 1/2. Well, that's 2/3 times 2, which gives me 4/3. So this is 4/3, and then it's 4a over 3 pi. Does that look right to you guys? Okay, excellent. And then we have m sub x. So what was m sub x? 2/3 ab squared over the same m from the previous work, 1/2 pi ab. And this looks very familiar, but this time it's the b that it remains. The a completely cancels. And then again, 2/3 times 2 would be 4/3. So I have 4b over 3 pi. So x, the center, or the centroid, x bar, y bar, is actually 4a over 3 pi, 4b over 3 pi. Any questions on that?